Hello. Now we will study about the Naïve based classifier. Before that, we would first start with the some concepts. Conditional probability. So conditional probability of a class C1 given that the feature x has value x is denoted as PC1 by x. So the CIs are the classes and x is a value which the feature x, small x, may take. So this P C1 by x tells us how likely it is that the class is C1 given that the value of x is capital X. Then we have this joint probability of class Ci and uh, xj, value xj. It tells us how often a measurement of x has the value xj and belongs to class Ci. Okay, so the value is xj and the class is Ci. Then we have another conditional probability that tells us how often feature x has value xj given that the example is a member of class Ci. So having given these definitions, we'll now move on to an example. So here it is. We have just one feature. For simplicity, we have taken one feature and we have two classes, no and yes. Okay, so whether having the three types: overcast, sunny, rainy. Three values can be acquired by the feature weather, and the target variable play has only two. So before we go on to compute the joint or conditional probabilities, we draw the frequency table. So for this, we would list out the feature and the target variable. If we had two features, we would have two frequency tables. So we can see how we get the values of overcast 4 against yes, because we will see here this is one time overcast yes, then second and third and fourth. With overcast, do we have the class no? No, we don't have it. So that is why this is blank, or rather it is 0. We come to sunny and yes, let us find out this one, another one, and we would have one more here. So this is, now it is probably clear how we make this frequency table. Now the class prior probabilities. So how many tuples of yes? We have totally 14, and how many tuples of yes we can count? It comes to 9 and no is 5. Now the probability of occurrence of this value rainy, as we said, weather has three values: overcast, sunny and rainy. So the probability of occurrence of rainy is how much? 2 and 3, 5. We can take a count. For a single feature, these values come out much more simply. So we gave this example. In some future videos, we'll take more than one feature and work out the example. So probability for the rainy value of weather and for sunny and overcast are also given. Now this conditional probability that the value of weather is overcast and the class is yes. So how do we find it? The value is overcast and the class is yes. So overcast value comes out for 4 positions and the yes is also in all the 4 tuples. So this comes out to be 1. Okay. Now, so this was given overcast, that yes would come up was 1. Now given yes overcast, Okay, it is this we are trying to find out, that the class is yes and the feature small x has the value capital X, or the feature weather has the value overcast. It tells us how often X takes this value given that the example is a member of class Ci. So member of class Ci, yes is, see it comes down here along this column. So now we'll see why making this frequency table is of use to us. So this column adds up to 9 and overcast is 4. So it is 4 by 9, right? Similarly, the other values, we have overcast yes, sunny and yes. So sunny comes out to be 3 times out of the 5 occurrences, it is yes, so 3 by 5. And overcast no, we have a 0 here, so it is 0. So all these value computations come out very simple once we make the frequency table. Okay, so we move on now. Now the Bayes rule. The probability xj and xj. Okay, given the class, the feature value is xj, or given the feature class is ci, are linked by the Bayes rule in this manner. Because both are related to the joint probability, pcixj into pxj gives the joint probability cixj, and similarly xjci, and this also gives. So we equate these two, and hence, see, for the classification problem, actually we want this. And we'll see this that the Naïve Bayes, this probabilistic classifier is not learning this. In fact, it is finding these out and then computing this. Okay, where in logistic regression we saw that we were trying to learn the probability of occurrence of an object in class C. Okay, so now we have this Bayes rule. Now from the previous example, we saw that overcast yes is 4 by 9, yes overcast is 1, and so on. So this joint probability P yes overcast is equal to P overcast given yes into P yes, because the other one is 0. I'm sorry, this actually we just multiply these two values and we get as 4 yes. Okay, P yes overcast, and if we wanted P no overcast, then our values would come out to be, because P overcast no was 0, so we would get a 0 value. So now we see how these two conditional probabilities are linked using the Bayes rule. Okay, we are simply working out simple examples to clarify the concept. So the Bayes rule relates the posterior probability, PCIXJ, with the prior probability and class conditional probability. And the denominator in the bottom of this Bayes rule formula is for normalizing. And to compute this Pxj, we can simply take this summing over all the classes Pxaci into Pci. So probability of P overcast is nothing by overcast yes into Ps plus P overcast no into P no. And we see that this is 0 and this itself gives us 14. We can just verify from the previous slide solutions. Of course, we have given out these values here also. Okay, so we get this P overcast equals to 4 by 14 by putting the values from here. Okay. Now, maximum a posteriori or map hypothesis. The Bayes rule is making us get the posterior probability by calculating the things which we can read from the data or which we can compute from the data. Okay, so we are obtaining the posterior probability by the computations from data. And having computed this these posterior probability for all the classes, we can assign this any data to a class by finding this. The class which has the highest PCI by X as compared to all the other classes Cj. Okay, when we have computed these posterior probabilities for all the classes, we pick up the highest one and say X belongs to Ci. And X is a feature of vectors. This is known as the maxima a posteriori or map hypothesis. And this allows us to choose which class to be given as the output class. So the naive Bayes classifier, what does it do? What it will find us, it will help us find the class to be output as the assigned class. But what we see is we want to compute from the data Px by Ci. Okay, so this Px is actually is a feature of which feature vector having many components. Okay, like these x1, x2, and so on. So here, to reduce this computation, to evaluate this, we have this naive assumption. This is the naive part of the naive Bayes. We assume, what is this naive assumption? We assume that the elements of the feature vector are conditionally independent of each other. So this feature vector, which was x1, x2, xn, so this is our the whole x data. These features are independent of each other given the classification. So given the class Ci, the values of the different features do not affect each other. So to compute this Pxci, we can take the individual probabilities of these elements of the feature vector and multiply them. See, product over all the features, right? This one. So how does the naive Bayes classifier work? Because now we have also found how to uh, find out this Pxci, or we are writing here as Pxy, or we have used this interchangeably, Pxci. So learn Pxy or Pxci and the Py, and then apply the Bayes rule to find the probability that X belongs to the class 1, and similarly we can do it for class 0 or other classes. And what is Px is simply the summation over all the classes. So Px in y equal to 1 multiplied by Py plus Px belonging to y equal to 0, or occurring in y equal to 0 multiplied by the prior. Okay, so all these also can be computed by looking at the data. So the naive Bayes algorithm works as computing the posterior probability of class C for a given value of x from the prior probability, from the class conditional probability, which is called the likelihood, and the evidence. So it does this for all the classes for the given vector, and the data point is assigned to the class Ci for which this it is the highest, the posterior probability is the highest. So I hope the working of naive Bayes algorithm is clear to you. In the next video, we'll work out an example and show it in detail. So thank you. Thanks for watching.